So let me do the next video on integration. See, if you can do this sum such as 1 by a root of x square plus a 2x plus 2 into dx. It is not like linear and quadratic, for you to assume t dt. It's just 1 by. So whenever there's 1 by, you can do it as a completion of square. So then 1 by x square plus 2 into 1 into x. Therefore with the plus 1, we'll make it, we'll get this, 2x. So plus 1 means you can write this 2 as another 1 plus 1. So this becomes a 1 by root of x plus 1 the whole square plus 1 square. The 1 can be written as 1 square. So now if you assume x plus 1 as t, a dx becomes equal to dt on differentiation. So this becomes dt by root of t square plus 1 square, which is log of mod of t plus quotient a copy plus e, which is log of mod of x plus 1 plus root of, see when it comes to copying a t, I'll copy from here. When it comes to denominator copy, I'll straight away copy this denominator, x square plus 2x plus 2 plus c. Right? It's easy for me to do it that way. So that's what it is. Okay, so the second sum, supposing it is like say 1 by a 9x square plus 6x plus 5, okay, integration. So you can write it as 1 by 3x the whole square plus this 6x can be written as 2 into 3x. So you got the 6x. So what is your a is this a square, so this is a, 2ab, so b can be 1. So then this 5 can be written as plus 4 because I want a b square which is plus 1. So I can write this as, from here to here I have a 3x plus 1 the whole square, which is 3x plus 1 the whole square plus 2 square, this 4 becomes a 2 square, and there is no root here, okay. So when there is no root, and this is like 3x plus 1 as t, 3 into dx as dt, so the dx becomes dt by 3. So it's dt by t square plus 2 square, dt by 3, yeah, 1 by 3. Because there's a coefficient, it's dt by 3 here, I'm differentiating, okay. So then this is like tan inverse 1 by a, which is 1 by 2, which makes it 1 by 6. Tan inverse of t by 2, so 1 by 6 into tan inverse of 3x plus 1 by 2 plus c, that's all. So that's only so little. So third question, like I'll tell you this pattern, if you see some pattern like this, 8 plus 3x minus x square, you see a coefficient of x square is a negative sign, then you have to adopt this pattern where in root kulla there should be no negative sign. So you should write something minus of, and this quadratic equation x square minus 3x minus 8, change the symbols and write it because you've taken the minus out common. Something minus, what is this? Now I'll do completion of square, something minus x square, it's an odd number, it's just 2 into 3 by 2, multiply and divide by 2 so that you get 2ab, yeah. So you get back a 3x when check that out, yeah. So what is b? B is this 3 by 2, 2ab, because this a square. So what is b? Is this, which is 9 by 4 minus 9 by 4 and minus 8, to bring it here. So in that case it will be 1 by root of something minus, from here to here it's x minus 3 by 2 the whole square, and this on solving is 8 4s are 32, minus 9 is minus 41 by 4, which is minus 41 by 4, which is here. So you can bring this that side on the question mark as plus 41, because minus of minus will become plus. So 1 by root of, you can write it as root 41 by 2 the whole square, because we need it in a square format, minus x minus 3 by 2 the whole square. Now if you assume x minus 3 by 2 as t, dx becomes equal to dt. So you can write this as dt by root of root 41 by 2 the whole square, root 41 by 2 the whole square minus t square. So it's 1 by root of a square minus x square, which is sine inverse of x by a, sine inverse of 2t by root 41, x by a. So this goes up, okay, plus c, and sine inverse of what is t? 2 into x minus 3 by 2 by root x minus 3 by 2 by root 41 plus c. So when you take LCM, the 2 and 2 get cancelled. It's 2x minus 3 by root 41 plus c. So that's all. So this is the way you have to do this sum. It's very important. Similarly, you have many sums wherein wherever in the root if you see x square munadi or negative sign, this is the pattern you have to follow. Next, Berle's most important sum is this, which is 1 by root of x minus a into x minus b into dx. So then in that case I would do x square minus a plus b into x plus ab into dx. Then I have to do completion of square, which is root of x square minus, it's like an odd number, so multiply and divide by 2, a plus b by 2 into x, which is b, is this b. So b square is a plus b by 2 the whole square. I can't randomly add a plus b by 2 the whole square, so I have to also subtract it with a plus b by 2 the whole square with a plus ab. So with the dx here, which will be 1 by root of x, from here to here, it's like x minus a plus b by 2 the whole square. When I solve this, I'll get minus of a minus b by 2 the whole square. So you try to solve it, you will get that, okay. So it's like 1 by root of x square minus, so you keep x minus a plus b by 2 as t, dx becomes equal to dt, so it's dx here, which becomes a dt by root of t square minus a minus b by 2 the whole square, which itself is like 1 by x square minus a square, the root, which is log of mod of t plus question a copy. T is here, from here you have to write. So x minus a plus b by 2 is t, mod of t plus question a copy. The question you have to copy from here, denominator, root of x minus a into x minus b plus c. So this is the way to do the sums. I hope you all understood. Whenever you assume it as t, when you have this pattern, this I didn't have to because it was sine inverse, okay, and in this there was no root, so I had to do tan inverse. In this it was x square plus root of x square plus a square, log of mod of, if you see t plus, in this I took this t plus question a copy, I took this question and copied. So that's the way I would do in every sum. I hope if you're clear with these 4 sums, you'll be able to try those sums in the textbook. I'll do one more question, which is a manipulation question of similar kind, where it's integration of 5x minus 2 by 1 plus 2x plus 3x square into dx. So if I see linear, I can't do completion of square because it's linear and quadratic, so it's t dt. So far I was doing completion of square because it was in 1 by. If it's linear and quadratic, obviously I have to do t dt, whereas 2 plus 6x into dx is equal to dt. So if you take 2 out common, 1 plus 3x into dx, or keep it like this, okay. So this is all you need. You see here randomly something else is there. It's a 2 plus 6x is what into dx, but it's 5x minus 2. So what you do, you have to take the 5 out. So it's x minus 2 by 5 by a 1 plus 2x plus 3x square into dx. Now you see this, there is a 6x here, can you see? So you have to multiply and divide by 6. So when you multiply and divide by 6, this becomes 6x minus 12 by 5 by a 1 plus 2x plus 3x square into dx. So then if you write it like this, now you got a 6, you managed to get a 6x, can you see? Then you want a plus 2, right? So what you can do is just add 2 and subtract 2. So when you do that, now you can split it, 5 by 6 is common for the whole thing. So you have a 6 plus 2 by 1 plus 2x plus 3x square, which is integration of, minus solving this part, it will be minus 10, so minus 22 by, minus 22 by 5. Is all I have. So I will just write minus here 22 by 5 into integration of 1 plus 2x plus 3x square into dx, and a dx here. Now this becomes like a t dt, this is t and this is dt. It's 5 by 6 in integration of dt by t, minus 22 by 5 into integration of 1 by, this is like 3x square plus 2x plus 1, wherein I will think of doing completion of square. But for completion of square, when I write root 3 and all, it gets very complicated, root 3x the whole square. So what I would prefer doing is like taking this 3 out. So 5 by 6 is anyway common for everything. This is 1 by t dt, which is log t, which is log t, which is log of 1 plus 2x plus 3x square, minus 22 by 5 into the completion of square. I would prefer to take this 3 out and so make it 15. The 5 3 is 15, and this will become an x square minus 2 by 3 into x plus 1 by 3 into dx. So if I do that, 5 by 6 into log of mod of 3x square plus 2x plus 1 minus 22 by 15 into 1 by, I have to do completion of square here, okay. So x square minus 2, a is x, b is 1 by 3 therefore, when I split this up, yeah, 2 is already there. So b square is 1 by 9, I can't put 1 by 9, I have to subtract 1 by 9 plus this 1 by 3 I have to bring in here. So then it's 5 by 6 into log of mod of 3x square plus 2x plus 1 minus 22 by 5 into integration of from here to here is x minus 1 by 3 the whole square. When you solve this, the LCM will be 9, 3 3s are 9. So it's minus 1 plus 3. Minus 1 plus 3 is 2 by 9. So with a plus 2 by 9 into dx. So then it's 5 by 6 into log of mod of 3x square plus 2x plus 1 minus 22 by 5 into, this is like 1 by x minus 1 by 3 the whole square minus root plus root 2 by 3 the whole square. There is no, there's no root here, sorry. So it's 1 by x square plus a square, which is tan inverse of x by a with the 1 by a, tan inverse of x by a. So a log of mod of 3x square plus 2x plus 1 minus 22 by 5 into log of, no, tan inverse 1 by a, 1 by root 2 by 3, it will become 3 by root 2 into tan inverse of x minus 1 by 3 by root 2 by 3. I didn't assume it as t, I could have assumed it as t, okay. I could have got dx by dt, I will still have to put the same formula, okay. So plus c. So when you solve this, it will be, if you are going to take the, this is a 5 by 6 outside, a log of 3x square plus 2x plus 1 minus this is 66 by 5 root 2 into tan inverse of 3 will get cancelled, 3x minus 1 by root 2 plus c is what I can think of is the answer for the sum, which is the 18th sum of the textbook. Let me see if my answer is right. 7.5 exercise. 7.5. Uh, 7.5, the sum number is 18. Okay. 5x minus 2 by 1 plus 2x plus 3x square and 7 point, I think that's 7.4. Yeah, the answer is 5 by 6, yes. Log of 3x square plus 2 minus, this is 11 by 3 root 3. How was it 11 by 3 root 2? Yeah, 11 by 3 root 2. 5 3s are 15, that's 22. So 22 by this was 15, right? Sorry, this was 15. So it was 15 and so I can cancel this. So this becomes 11 by 3 root 2. I hope you had identified my mistake. If you've done well and good, this is a way to do the sum, okay? So sum is over. So these are the patterns that you should follow, and you know, these are called manipulation. You just assume it as t. Make sure that you're getting in the form of dt on the top, and you can split it, you know, this one as separate and this one as separate, splitting the denominator. You can write as two different terms. One is t dt, another will be completion of square. So first itself you can't do completion of square when it's linear there, okay. That's the point you should understand. So this covers the important sums in this exercise, and with this you can build up and do the rest of the sums. Exercise 7.5. And the moral of the story is, supposing it's x by x plus 1 into x plus 2 into dx. I told you this is to be solved like a partial fraction. There's a different chapter called partial fractions in state board or any other syllabus, but in CBSE you don't have that. It's not about integration, it's about anything like this can be converted into addition, such as a by x plus 1 plus b by x plus 2. In that case, if you take LCM, it will be a into x plus 2 plus b into x plus 1 here will be equal to x, because the denominator of both these terms will get cancelled. So if you assume x is equal to minus 2, because this will become 0, it's convenient, and x is equal to minus 1, This will become minus 2 is equal to, this will become 0. So minus 2 plus 1 is minus b. So therefore you get b is equal to 2. Now if you put a is equal to minus 1, you get minus 1 is equal to minus 1 plus 2, which will be just a. Yeah, so then therefore a is equal to minus 1. So you get a and b, you can directly substitute in this. What is a? It's minus 1 by x plus 1. What is b? It's 2 by x plus 2, and you just put an integration symbol and dx with it. This will be minus of log of mod of x plus 1. And this will be plus 2 into log of mod of x plus 2. You can take the 2 out and be 1 by x plus 2. It's like 1 by t format, log t plus c. And whenever you see something like this, you can take it to the top, and whenever you see a negative sign, you can write as 1 by x plus 1 plus log of x plus 2 the whole square plus c, and this is addition, so it will become multiplication. You can do like this and also write the answer depending on whatever is the answer. Exercise 7.5, the first sum, yes. The log always have a mod. So when it's a square, you don't have to specify because anyway positive. So this is the way you have to do. And if it is this pattern, if it's linear, two terms of linear, you should split it up like this. Okay. So next sum is 1 by x square minus 9 into dx. It's direct formula, you don't have to do it as partial fraction. It's 1 by x square minus a square, which is 1 by 2a into log of mod of x minus a by x plus a plus c. So let's go to third question, which is 3x minus 1 by x minus 1 into x minus 2 into x minus 3 into dx. So this becomes a by x minus 1 plus a b by x minus 2 plus a c by x minus 3. So when you take an LCM, so it will be, what will that be? Both the denominators will get cancelled, that it would have been a into x minus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 c into x minus 1 into x minus 2 is equal to 3x minus 1. Now you assume x is equal to 2. You assume x is equal to 3. Then you put x is equal to 1, because when you do that, x is equal to 2, this whole term will get cancelled. Put x is equal to 3, this whole term. Like that you can easily solvable for a, b and c. So put x is equal to 2, this is 3x minus 3 to 6, so it's 5 is equal to, this will become 0. This will also become 0. You only have the middle term. 2 minus 1 is 1. 2 minus 3 is minus b. Therefore, b is equal to minus 5. Putting x is equal to 3, 3 3s are 9, 9 minus 1, 8 is equal to, so this will become 0 again, this will become 0, only this term will exist, which is 3 minus 1 is 2, and a 3 minus 2, 3 minus 1 and a 3 minus 2 is 1, so 2c. And c is equal to 4. Putting x is equal to 1 here, as 2 is equal to, this the only term which will exist, because rest of it will become 0. So a into 1 minus 2 is minus 1, and a 1 minus 3 is minus 2, minus 1 minus 2 is just 2, so a is equal to 1. I hope it's right. Just check it. 1, 3 minus 2 is, okay, 1 minus 2, 1 minus 3 is minus 2 and minus 1, so yeah, 2a is equal to 1. So substituting all a, b and c back, you get 1 by x minus 1 integration dx plus b is minus 5, so you can always take it out, minus 5 1 by x minus 2 dx plus c is plus 4 integration of 1 by x minus 3 into dx, which is log of mod of x minus 1 minus 5 into log of mod of x minus 2 plus 4 into log of mod of x minus 3 plus c. So that's all is your answer, okay, whatever you get. Okay, so what is this? This is the third one, which is 7.5. And check the answer. Yes, it's right. You don't have to make it into multiplication, logarithm and all, you can forget about it. Okay, these are the patterns whenever you have fifth sum. If you see 2x by x square plus 3x plus 2 into dx. Okay, this is just t dt. I could have solved it as t dt, but the whole thing is using partial fraction, for which you should factorize. In that case, it's x plus 2 into x plus 3, x plus 1. When you solve this, you get that. Okay, so it's a by x plus 2 plus b by x plus 1. So a into x plus 1 plus b into x plus 2. The denominator will be x plus 2 into x plus 1, and it will be 2x by x plus 2 into x plus 1 So denominator get cancelled, yeah. So we can equating these two, you can assume x is equal to minus 1 and x is equal to minus 2 alternatively, and find it will become minus 2 if you assume minus 1 the left side, and this will become 0 and this term will become minus 1 plus 2 is b. So b is equal to minus 2 is that, and minus 2 if you assume it will be minus 4, and minus 2 if you put here, minus 2 plus 1 is minus a. This of course will be 0, so a is equal to 4. Once you get that, substituted back here, so it's 4 into integration of 1 by x plus 2 into dx, minus 2 into integration of 1 by x plus 1 into dx, which is 4 into log of mod of x plus 2, minus 2 into log of mod of x plus 1 plus c, that's all. So these are the patterns in which you can factorize, but if you see the seventh sum, it's got x by x square plus 1 into x minus 1, which is quite different. Can you see it's non-factorizable? So in that case you should write ax plus b by x square plus 1 plus c by x minus 1. You have to make it into linear on the top. So these are the properties you should use while converting into simpler terms. So to find, now you will take LCM. So you know it's ax plus b into x minus 1 plus c into x square plus 1 is equal to x. So this is what it is. So if you substitute x as 1, this will become 0. So it will become 2c. Yeah. So 2c is equal to 1, c is equal to 1 by 2. Then what else can you substitute? So then know the options. So then you can substitute x as 0, x as minus 1, whatever you want. X as 0, if you put 0 is equal to, this is just b into 0 minus 1 is minus 1 plus c into 0 plus 1 is just 1. So minus b is equal to, minus b plus c is equal to 0, b is equal to c. So you know b is equal to c. So if c is 1 by 2, b is also 1 by 2. So that's about that. Now you don't know still what, yeah, you found b and c, you don't know what is a. So now substitute x as say minus 1, just like that, okay. Know the go, minus 1 is equal to minus a plus b into minus 2, minus 1 minus 1 minus 2 plus c into 1 plus 1 2. So when you bring this in, is minus 1 is equal to plus 2a minus 2b plus 2c. So it will be minus 1 by 2 is equal to a minus b plus c. You know b is equal to c from here. So these two get cancelled. So a is equal to minus 1 by 2. Once you get a, b and c, you can directly substitute in this equation. Is ax plus b is minus 1 by 2 into x plus 1 by 2 by what is in the denominator is x square plus 1 plus c by x minus 1. What is c? Whatever is c, c is also 1 by 2, 1 by x minus 1 into dx and dx. So now you see you can take the 1 by 2 out. I don't even want the negative side, right? So it will become x minus 1 by x square plus 1 into dx plus 1 by 2 into mod of x minus 1 into dx. Now I'll split this up because I'll get a t dt, and next is direct formula. So minus 1 by 2 is common for this entire term. So it's integration of x by x square plus 1 minus integration of 1 by x square plus 1, which is direct formula, you all know. This is t dt first term, plus a 1 by 2 into integration of 1 by x minus 1 into dx. Now this is common, 1 by 2 minus 1 by 2 is common only for this, okay. It's 1 by 2 which is common for these two, okay. So minus 1 by 2 into t dt, so this will be log t, which is log of mod of x square plus 1, and this will be direct formula tan inverse of x, and plus half into, this is log of mod of x minus 1 plus c. So we'll check the answer for this sum whether I got it correct. The very important sum, this is 7.57 sum. This is 7.57 sum. So if I bring the half inside, it will be minus 1 by 2 into log of mod of x square plus 1 plus tan inverse of x by 2 plus half log of mod of x minus 1 plus c. This should be your answer. I got the answer, I think. 1 by 4. This says 1 by 4 log of mod of x square plus 1. Otherwise everything looks okay. Only this part. Okay, how is it 1 by 4? Let's go backwards. And yeah, because t dt is, I didn't write that. X square plus 1 as t, 2x into dx as dt, and x dx is what is there. So I'll get a 1 by 2 into here. The 1 by 2 will already be here. So it will become minus 1 by 4 into. That's the only change. I hope you noted down the change. Very, very important sum. Okay, so this is when it's non-linear. When it is non-linear, see, and it's non-factorizable, you have to convert it as linear ax plus b. Okay, so you can also write it as a by x minus 1 plus bx plus c by x square plus 1 also you can write. It's up to you how you want it, doesn't matter. Okay, so that's about this sum. So let's go to next pattern, which is x by x minus 1 the whole square into x plus 2. So in this case you write, it will be a by x minus 1 plus b by x minus 1 the whole square plus c by x plus 2. So when you take LCM, this would be a into x minus 1 into x plus 2, you know, a into x minus 1 into x plus 2 plus b into x plus 2 alone plus c into an x minus 1 the whole square is equal to x. So that's all. In whole square, this is the format you should follow. Okay, x minus whole square means it's like this. X square plus 1 means a linear by x square plus 1. Okay, previous one. X square plus 1 is a non-linear quadratic. This is the quadratic, but whole square format is different. This is the way you should do, and then you can solve it. Put x is equal to 1, x is equal to minus 2 and all, and if you can't find the answer a, then you put x is equal to 0, find a, b, c and substitute it there and then integrate, that's all. Okay. So any doubts, please contact me and ask me. If you can't integrate or anything, let me know. So this is about 8th sum, and this pattern I am sure you understood. Okay, even 13th sum, if you see the question, it's got 13th question. If you see, it's 2 by 1 minus x into 1 plus x square, which is a by 1 minus x plus bx plus c by 1 plus x square, because it's non-factorizable and it's not whole square, it's a different format. So like this, and then solve it, you get the answer. Okay, then next is 14th sum, 3x minus 1 by x plus 2 the whole square. A whole square is there, so a by x plus 2 plus b by x plus 2 the whole square, and then take LCM and solve it. Okay, so I have omitted the 6th sum, the 12th sum, and I will do it later in the video. Okay, so 15th also I am not doing. Okay, I am going to 17th directly. I am doing similar sums together. 1 minus sin x into 2 minus sin x into dx. So you have it like this. If sin x is t, a cos x into dx is equal to dt. So this becomes a dt by 1 minus t into 2 minus t, which is a by 1 minus t plus b by 2 minus t, which is to find a and b, just have to take LCM, and the sum becomes an ordinary partial fraction sum after this. Okay, then after the 17th sum, you should only try the 22nd sum, which is x by x minus 1 into x minus 2. You can always do these sums linear and quadratic, you can do t and dt after multiplying inside, but as partial fraction, then you should do a by x minus 1 plus b by x minus 2 and then equate it and find what is a and b and do the sums. Very simple. So 23rd question is dx by x into x square plus 1. In this case, as partial fraction, if you want to do, you only can do partial fraction because it's not t dt, or not, it's quadratic for you to do completion of square, because it's x into x square plus 1. So a by x plus a bx plus c by x square plus 1. So this is the format, and so when you take LCM, plus a bx plus c into x is equal to 1. This is just this is just 1, yeah, right, 1 dx. So equate it to 1, substitute x as 0, x as 1 and all that, and find what is a, b, c, and then substitute it back here. These are the forms. Okay, now I am going to teach you the 6th question, which is the world's most important. So 6th and 12th sum are very important, such as 1 minus x square by x into 1 minus 2x into dx. See, in this kind of sums, when I do partial fractions, the most important factor is the numerator and denominator should not have same powers, or the numerator cannot have a bigger power than the denominator. That is the rule in partial fraction. So if you see, this is 1 minus x square This will be x minus 2x square. So, see the powers are the same. The numerator cannot have a lesser power or equal power as the denominator. If you see previous sums and all, it is only linear and quadratic. The numerator had smaller power. So, in such sum, before doing partial fraction, you are supposed to do long division. Such as you are going to divide minus x square plus 1. Rearrange and write this. You are going to divide it by x minus 2x square, or rearrange this also, minus 2x square plus x. So, when you do that, can you see that there will be a 2 here, there will be it will be a 1 here, because this multiplied by 1 will give you minus, no, it has to be 2, so then minus 1 by 2, sorry, it has got to be 1 by 2. That is when you multiply this and 1 by 2, you get minus 2x square plus x into 1 by 2, which will be a minus x square plus 1. Oh yeah, you got what you want. So 1 by 2 will give you minus x square plus 1. So a plus and a minus, so it is becoming 0. So you divide the numerator by the denominator by long division method. You write quotient plus remainder by divisor. Okay. Okay, it's x by 2, right? It's not 0. Okay, let me do this sum once again. So I am writing minus x square plus 1 and a minus 2x square plus x here. Okay, and what I am doing is I want to get this x square, so I know it's 1 by 2. So when I put minus 2 here, it will be minus x square, no doubt, when I multiply this with this, but it will be x plus x by 2, I forgot that. So it's plus and minus, this get cancelled. So it will be minus x by 2 plus 1, in other words. So that's all. It has now become, the x square and x square is solved. It's become linear now. So you have to write quotient plus remainder by divisor. Quotient is 1 by 2 plus remainder by divisor. Divisor is this divisor, right? This is also the same as what is minus divisor, yeah, this is the same as this divisor, so it's x into 1 minus 2x, you can write like that, and a dx here and a dx here. So quotient plus remainder by divisor format, a quotient plus remainder by divisor format is what you need to follow whenever the numerator and denominator have same powers, or numerator has a greater power than the denominator. You have to continue like that. So this will be 1 by 2 into x plus this I am going to do t dt. And if you see, take this in, it's minus x by 2 plus 1 by x minus 2x square into dx. So x minus 2x square is t, 1 minus 4x into dx is equal to dt. So it will become x by 2 plus integration of minus x plus 2 and a 1 by 2 out by x minus 2x square. So you see, you have to have 1 minus 4x into dx. A minus 4x you need, but you have a minus x. So multiply and divide by 4. So x by 2 plus 1 by 8 into minus 4x plus 8 by x minus 2x square dx. Now you want a minus 4x plus 1 here. Can you see plus 1? So you can write as plus 1 plus 7. The 8 can be written like that. Now you can split it like this and then split the other one. X by 2 plus 1 by 8 into integration of minus 4x plus 1 by x plus 2x, x minus 2x go into dx. And this 1 by 8 is common for that also. And 7 is taken out common, 1 by x minus 2x square into dx. So when you do this, it will be t dt here, hopefully, yeah, it's t dt. We got in the format which is log t, which is log of mod of x minus 2x square, plus a 7 by 8 into, what would this become? So I don't want a negative sign here, so I can take the negative out and write as 1 by 2x square minus x into dx, and I can do completion of square here, but for that I don't need this 2, I can't write root 2x the whole square, I have a problem there, so I'll take the 2 out. Can you see how lengthy the sum is? Plus minus 7 by 8 to 16 by x square minus x by 2 into dx. So to do a completion of square, x square minus 2 into x by 4 is x into 1 by 4 plus 1 by 16 minus 1 by 16. So it will become minus 7 by 16 into integration of 1 by x minus 1 by 4 the whole square minus 1 by 4 the whole square. So it's like 1 by, no root there, 1 by 2a into log of mod of, so minus 1 by 7 by 16 into 1 by 2a, yeah, x square minus a square, yeah, 1 by 2a, 2 into 1 by 4 which is 1 by 2, so 2, this and this anyway get cancelled, to log of mod of x minus a by x plus a. This and this get cancelled. No, this and this doesn't get cancelled. Denominator gets cancelled. Yeah, and this. So minus 7 by 8 into log of mod of x minus 2 by 4 is minus 1 by 2 by x. I don't know if my answer is right. It's such a huge sum, 7.5. Let me check my answer for the sixth sum. So I already have an x by 2. Okay, I already have an x by 2. I have a 1 by 8. Is it, how did I get the 1 by 8? X by 2 plus 1 by 8. Yeah, multiply it and divided by 4. Yeah, so it will be 4 to the 8, 1 by 8 minus 4x plus 1 plus 7 by 8. Log of 1 minus 2x log x. Okay, I think what they seem to have done is for this, solve this, you get a 2x minus 7 by 8 into log of mod of 2x minus 1 by 2x is what you get, right? Then I'm trying to figure out x by 2 is there, and a 1 by 8 into, if you take a log of x into 1 plus 2x, and so this can also be written as x by 2 into, this is logarithmic multiplication, which can be written as addition. So 1 by 8 into log x plus 1 by 8 into log of 1 plus 2x, say minus 7 by 8 into log of mod of 2x minus 1. This is subtraction, logarithmic subtraction. So minus 7 by 8 will become plus 7 by 8 into log of mod of 2x. In fact, it's log 2x, which is log 2 plus log x plus log x plus 7 by 8 into log x or something like that. Yeah. So this 1 by 8 log x and a 7 by 8 log x, 1 by 8 log x plus a 7 by 8 log x will just turn out to be a 1 log x. Yeah. So it's just x by 2 plus a simple log x. And if you see this and this, is it solvable? Let's check that out. Log of 2x minus 1 is log of 1 minus 2x. Yeah, you can write it as 1 minus 2x because it is within mod, doesn't matter. Yeah. But this is log of 1 plus 2x. Oh no, it's 1 minus 2x. I'm sorry, this is also 1 minus 2x. So these both are same like terms. You have a 1 by 8 into log of mod of 1 minus 2x minus 7 by 8 into log of mod of 1 minus 2x. When you subtract this, you'll get minus 6 by 8, which will become a minus 3 by 4. So can you see this becomes a minus 3 by 4 into log of mod of 1 minus 2x. There's so many consolidation to get the answer. Such a huge sum and a very, very important sum. So I struggled, I missed some parts. I hope you're very clear with all this. Rewind it and become very clear. Write it first. Whatever mistakes I've done, please correct it and write it, because I'm doing this sum in front of you. I'm not copying from anywhere. According to me, this sum is a very important sum. So next sum is x cube plus x plus 1 by x square minus 1 into dx. So immediately I know the numerator has got greater power than the denominator, so I'll do long division. and I'll divide it by x square minus 1, which multiply by x, you get an x cube minus x. This minus and plus, and this will be 2x plus 1. So I told you a quotient plus remainder by divisor, because now the power has become lesser. So quotient is x plus remainder dx, plus the remainder is 2x plus 1 by divisor is x square minus 1 into dx. Now this becomes t dt, that's all. This is x square by 2. The sum is fairly easy when compared to the previous sum. When x square minus 1 is t, 2x into dx is dt. And you see a 2x, so I have to split it in two different terms. Plus 1 by x square minus 1 into dx, where this is direct formula, this is t dt, x square by 2 plus this is t dt, which is log of x square plus 1, plus this is 1 by x square minus a square. What is 1 by x square minus a square? What is 1 by x square minus a square? As x square minus a square, 1 by 2a into, yeah. So 1 by 2a into log of mod of x minus 1 by x plus 1 plus c. So the sum is fairly easy, right? The 12th one, I didn't struggle at all. Not even one bit of struggle here. Yeah, and I'm just cross checking my answer. 1 by 2 into log of mod of x. Let me check. This is the 12th sum. Log of mod of x minus x plus 1. Well, the answer is pretty different. Why? What is the mistake again? 2x, x square minus 1 is t, 2x into dx is dt. Split this up. You get 1 by x square minus 1, which is 1 by 2 into log of mod of x minus 1 by x plus 1. This is t dt, which is log of x square minus 1, sorry, log of x square minus 1. Oh yeah, we can continue because it's not x square plus 1, it's x square minus 1. So x square by 2 plus log of mod of x square minus 1 plus half of log of x minus 1, and you can write this as, actually you can make this into multiplication, right? That is root. So do one thing, you can write this as x plus 1 into x minus 1, so it will be log of x plus 1 plus log of x minus 1, because logarithmic multiplication will become addition, plus half log of mod of x minus 1 minus half log of mod of x plus 1 plus c. So if you see this and this is 3 by 2. Okay, if you consolidate this and this, it's just half log of x plus 1. So you get the answer, book answer, into half log of mod of x plus 1 like terms, and plus a 3 by 2 into log of mod of x minus 1 plus c. So this is the sum, these two sums are the sums that I left. I didn't do it in the class, but they are pretty difficult. It's not as easy as you think. So please practice it many times, especially the 6th sum was a nightmare for me. So 15th sum is 1 by x to the power 4 minus 1 into dx. So okay, I don't want to do 15th. I'm keeping the 15th sum, 15th, 16th, 18th, 19th and 21st is pending. I'll deal with it tomorrow. Make sure you're learning till here, okay?